So we are going to talk about properties of rhombi and squares, first focusing on rhombi. A rhombi has the same properties of the parallelogram that we talked about last week before we did rectangles, and it has all those same properties that are listed here. Okay? And it has an additional 3 properties that says all four sides are congruent, the diagonals are perpendicular to each other. So not only do they bisect each other, as we did in parallelograms, but they are perpendicular to each other, meaning 90 degrees. So I wrote that in parentheses. And then diagonals bisect the opposite angles. So not only do they bisect each other, again, they bisect the angles that they go through. Okay? Now, it does not contain the parallel or the rectangle properties of having the diagonals being congruent or the 4 angles being right angles. It does not have those because these are just a rhombus. Okay. So we're going to start with this problem here. We know that JK is 12. And then we know that JN is 7. Okay. And we are asked to first find JM, okay, which is this. All right. Well, since it is a rhombus, if you go up here, it says all 4 sides are congruent. So if I come back down here, I know that actually all of these sides are 12, meaning that JM is 12. Okay. We are then asked to find JL, and JL is this entire segment here. And we know that diagonals are bisected. So if JN is 7, then NL also has to be 7. So if I put those 2 sections together, it gives me the full length of that diagonal as 14. MN is this section here that we are trying to find. And if you notice, we did say that diagonals are perpendicular, so that means that's a right angle. We have a right triangle. So we're going to use Pythagorean theorem to find MN. If you have 2 of 3 sides of a right triangle, you can use Pythagorean theorem. Pythagorean theorem says I'm going to square my 2 legs and add them and equal to the hypotenuse. So I'm going to have a squared, which will be my variable, or let's just call it x. So I'll let this be x. Plus 7 squared, the other leg. Again, the legs are the ones that are attached to the right angle. So you see the x is touching the right angle and the 7 is touching the right angle, equal to 12 squared, which is opposite the right angle. The hypotenuse is the longest side. I'll go ahead and simplify so that I can begin to solve this. I'll subtract 49 from both sides so that I have x squared is equal to 95. And then I'll square root both sides, and I'll get approximately 9.7. Okay, that's what I have there. Right. So this is not x anymore. It is 9.7. Right. Now it asks for MK, which is this entire diagonal. So if that part is 9.7, then this part is 9.7 because diagonals bisect each other. So I will do 9.7 plus 9.7 to get MK. So I will get 19.4. Moving on to the next example, we have EF is 23, which means all of these sides are 23 because it's a rhombus. So I'm going to go ahead and fill that in just in case it becomes useful. And I know that DF, this entire segment here, I know it's 40. Okay, so just in case that's useful, go ahead and mark it down. And just remember that that's a right angle. That also might be helpful. So GF is what we're first going to look for. And GF is this, and we already said it's 23 because all the sides of a rhombus are equal, 23. All right, then we're going to look at HF, and HF is this part right here. If you notice, it's part of that diagonal that's 40, and diagonals bisect each other. So I can do 40 divided by 2, and I will get 20 for HF. Then I'm going to be looking for GH, which is this segment here. Okay, so I have this as 20, I have this as 23, and I am looking for this. So I will let that be X. Okay, and again, that's a right triangle, and we have 2 or 3 sides, so we're going to use Pythagorean theorem. So I'm going to take the 2 sides that are attached or adjacent to the right angle, and I'm going to square them. Those are your legs. And then I'll equal it after I add them to the hypotenuse, which is opposite the right angle, opposite meaning not touching it, 23 squared. And I'll go ahead and simplify that. And I'll subtract 400 from both sides, square root both sides, and I'll get x is approximately 11.4. Why don't we just round to the nearest tenth? Okay. GE is, so that was GH. So here is 11.4, meaning this is also 11.4. So if I'm looking now for GE, I'm going to add 11.4 plus 11.4, giving me 22.8. Moving on down to number 3. We have RT is 22, and US is the other diagonal, and is 18. Okay, so we have those 2 measures, which means that, again, we have this right angle, but that each of the sections for the diagonals are split in 2. So this is, if this RT is 22, this part is 11, and this part is 11. If that US is 18, this part is 9, this part is 9. How did I get that? I did 11, or I did 22 divided by 2 to get 11, and I did 18 divided by 2 to get 9, because that's what a bisecting means, is cutting in equal parts, and those diagonals bisect each other. Now we're looking for VT, and VT we just decided was 11 because we did the entire RT divided by 2. UV we calculated to be 9 because we did the entire diagonal 18 divided by 2. Now RS, I'm going to erase these parts here that I don't need right now. RS is this diagonal here, okay, which is part of this right triangle. And I know 2 of the 3 sides of this right triangle is 11 and 9. Now, benefit to this, we don't have to do the subtraction we did before, because I know the 2 legs, the 2 sides attached. I know them, so they'll be together equal to x squared. And so we'll let this hypotenuse be x. So I will simplify. Square root both sides after you get them added, and I'll get x is approximately 14.2. Then it's asking for xt, which is another side. So if this side is 14.2, so is every side, because it's a rhombus. Number 4, we're just going to look at angles now, where we were looking at segments. Okay, so we have 38 degrees, and that's the only piece of information they gave us, except for the fact this is a rhombus. So if I work my way around, I'll be able to find different pieces. So if I know that this is 38, then this also has to be 38, because the angles have been bisected and opposite angles are equal. So this is 38 and this is 38. Okay, very, very helpful. What we also know is that consecutive angles, these 2 entire angles, add to 180. So if I subtract both of those 38s away, I get 104. And that means this entire angle is 104. But again, these 2 are equal, so I need to split it equally 2 ways. So I will do 104 divided by 2 so that I get 52 for both of these angles, meaning I have now found angle 1 and angle 2, because those angles are bisected. Angle 3 we already found as 38 because the angles are bisected. Angle 4, using alternate interior angles or opposite angles being equal, is 38, as is 35. Okay. And then measure of angle 6 is going to be opposite interior angles. with that 52, so it's also 52 degrees. And then angle 8, if you remember that diagonals are perpendicular, means that this is 90 degrees. Go on to the last problem here. We have ZY as 34. We have WX or WY as 38. So this whole thing is 38. And we have ZXY as 34 degrees. Okay, so you can use those to help trace. I'm going to zoom out so I can see what I'm being asked for. Okay, so we are first being asked for WZ. And WZ is one of the sides of my rhombus. And we know that all the sides of a rhombus are equal. So WZ is also 34. VY is this section of the diagonal, and we know the diagonals are bisected. So I'll do 38 divided by 2, and I'll get 19. So VY is 19. And then ZV is this part of the diagonal. So if I look at this, I have this right triangle where this is 19, and I have the hypotenuse as being 34, and then I'm missing the other leg, so we'll call it x. So I'll do x squared plus 19 squared equals 34 squared. If I square each thing and subtract the 19 squared over to the 34, I'll get x squared is equal to 795. If I square root both sides, I'll get x is approximately 28.2 when I round to the nearest tenth. So just this part is 28.2. ZS is asking for this whole thing, so I'll do 28.2 plus 28.2 when I add those sections together, or 28.2 times 2, and I'll get 56.4. Now, moving on to our angles, I'm going to get rid of some of the segment stuff so I can focus, is WXZ. And WXZ is this here. And we know that angles are bisected, so this also has to be 34. Next is WVZ. WVZ is here. And we know that diagonals are perpendicular, so it has to be 90. Then we have ZYW, which is this angle down here. Okay. And we'll have to work a little bit harder at that, but we know that this angle altogether is 34 plus 34, so 68. And I know that these two angles are going to be supplementary to each other, so I can do 180 minus 68, and that's going to be 112. And I'll need to divide that by 2 to split it equally to those two angles. And so I will get these two angles as 56, which is what I'm asked for in ZYW being 56 degrees, and XYW is being the other 56 degrees. Okay. Moving on to squares. Squares have all the properties. So everything we've learned at this point is all inside a square. So we are going to work on this. So we have AD being 11, and we're going to find every missing value. Okay. So in order to find BC, it's going to be opposite sides being equal. It's also 11. All right. Then it wants us to find AC, which is here. And since all sides are 11, I'll use the Pythagorean theorem, because these are all right angles because it's a square, with 11. And I'll let the diagonal be x. And I will solve this, okay, carefully. So I will do 11 squared plus 11 squared is going to be 242. Square root both sides. And I get x is approximately 15.6. It asks then for the other diagonal, BD, and in a square, your diagonals are equal, so it's also 15.6. And then it asks for EC, which is this part of a diagonal, which is going to be 15.6 divided by 2, which is 7.8. Then we're going to go and do our angles. Okay, it wants to know DAB, and DAB is going to be a right angle. It wants to know AEB, and the diagonals intersect at a right angle. It wants to know CBD. Okay, we know that the angles are bisected, so we'll have to do 90 divided by 2, so we'll get 45. And then we need to do BAC, which again is a 90-degree angle being bisected into equal parts, which is another 45 degrees. PQRS being a square, this is exactly like the one we just did, so we're going to go ahead and move past it. If you need extra practice on it, that's a good one to do. But let's go ahead and do this rhombus. We know the opposite sides of a rhombus are equal, and we're looking to find MP. So if I can find either of those sides, all the sides are equal, so we'll be able to find MP. So we will first set equal our two equations. Okay. I'm going to subtract 3 from both sides. At the same time, I'm going to add 77 to both sides so that I have 6x is equal to 84. Divide both sides by 6, and I get x is equal to 14. Now I'm looking for MP. I can plug it into either equation. I think it'd be easiest to plug it in here, so I'll do 3 times 14 plus 7, and that'll give me that MP is equal to 49. Going on to number 9, there's a couple different ways you could do this, but since this is a rhombus, okay, and it is not a square, we know that these two angles, they're going to be equal to each other. Okay, if they're a square, we could add them to 90, but they're not. And so we'll do 5x plus 1 is equal to 8x minus 20. And the reason we need to find x is because we're looking for FED, which is this angle here. So if I can find this entire angle here, I can subtract from 180 and get that. So let's first find x, and I'm going to minus 5x from both sides, and I'm going to add 20 to both sides so that I can get 21 is equal to 3x, divide both sides by 3 so that x is equal to 7. Then I need to plug it in to one of these equations, and then I can find that entire angle very carefully. And so if I'll find, let's actually plug it in this one, it'll be easier. So I'll do 5 times 7 plus 1, so that'll be 36. So just half of this is 36, which means this guy's also 36. So that entire angle F together is going to be 36 plus 36, which is 72. So this angle here is 72 degrees. If I need this angle here, I'm going to do 180 minus 72 degrees, which is going to be 108, because consecutive angles are supplementary. All right, now this is a square, so always pay attention to the information you are given. Okay, since that is a square, you are going to be looking at this being SW and this being WU, and we know that diagonals are bisected, and we're going to be looking for VT, which looks like a whole other thing, but the diagonals are also equal. So I'll use that x to find that. So I'm going to set equal 2x plus 13 and 8x minus 41. I'm going to subtract 2x from both sides while adding 41 to both sides so that I get 6x is equal to 54. I'll divide both sides by 6, and I'll get x is equal to 9. Then what I want to do is I want to find the length of this. If I can find the length of just one part, okay, doubling it would give me the whole diagonal. So if I look at just SW, just here, 2 of those is going to be equal to this because the diagonals are equal. So I'm going to do 2 times 9 plus 13 and get 31. And then I'm going to do 31 times 2, and I'll get that full diagonal as 62. Number 11, it is still a square, and we're solving for x. And they only gave me this one angle, which looks like that might be hard, except for I know that this is a right angle, and that angle has been bisected. And so bisected means cut into equal parts. So if I divide 90 by 2, that angle has to be 45 degrees. So I can just do 7x plus 3 is equal to 45 degrees. I'll subtract 3 from both sides, and I got 7x is 42. Divide both sides by 7, and I'll get x is equal to 6.